Hello. Today I'd like to continue what we were doing last time, using MonoGame to make your game. And so with this, you'll see that I've already got the page open to the official monogame.net site. And on the right side, I've got my simple breakdown, trying to make it less words, so that you can follow that if you want. Go to the official documentation for more details. What we're going to be doing is adding a simple image and then moving that image around, just like is in adding content and adding basic code. Nothing special, nothing spectacular. If you know this, skip this video. Okay, so first you have to obtain an image somehow. You can create your image in Paint or GIMP, Sprite, doesn't matter what you use. Alternatively, you can use free assets. A good source of that is Kenny. There's a ton of other places as well. Just make sure that you follow the attribute and acknowledge the art, or pay for the art or whatever. So we're just going to make a quick image here. Let's open up Paint, and I wanted to show you this because some people don't realize, I don't know why, but you can do all of this right in Paint. I've turned off aspect ratio. I set the pixels to 64 by 64. Now I'm going to zoom in, and we're just going to make some really simple thing. Let's just do an arrow. How about that? We will do a simple little red arrow. Nothing fancy. And we'll fill that with blue. How about that? We're going to save this image. Doesn't matter where we save it. Let's just save it to the desktop. And we'll call it arrow. Now that we've got that arrow created, let's go ahead and register the arrow with the MonoGame Content Builder. This will allow you to take the image and tell MonoGame where that image is located so it can compile that into the correct format to be used by the MonoGame framework. To do that, we're going to want to open up Visual Studio. Open up our project. Over on the side, under Solution Explorer, you're going to expand the project, then you're going to expand content. Double click on content and you might get an error. Right click, add existing item. Go ahead and find that image that's on your desktop. Select it, open. Here we're going to say copy file to the directory and click add. Now it is here. Just to show you some information, we want to make sure the importer and the processor are both showing texture. That's how we know it's working. Okay, so you want to build it, go to build, build, and then from here you can see it's green. Sometimes this can help with troubleshooting. If you go through the build process, you don't see this. If it's not green, then there's an issue. Okay, file, save, and then exit. Open game1.cs. Let's go ahead and add a variable to store the texture or the image. We're going to put that at the class level. So my texture 2D, or rather texture 2D my texture. And then we're going to load that texture from the file into memory. So if we go down to the load content method, the load content method is where we're going to want to add in this line of code. Now we named it arrow, so we're going to have to rename this from, and it doesn't matter that this arrow is a different name than the actual. They can be different. Load the image into memory, but it's not going to show the texture. So let's run this. as you can see right here, it shows a blank screen. We don't get any errors, but our image is not being displayed because we've loaded it into memory, but we have not drawn it. So let's draw it. So we're going to go down to the draw method, and we are going to add in 3 lines of code to draw that. Sprite batch begin, sprite batch draw, and sprite batch end. Now, the sprite batch begin has a bunch of different overloads to that begin method. What that simply means is that we're using the defaults, but there are other options. There are other draw methods you can perform, or different ways you can draw. So the begin method, as you can see right here, has all these other variables. We are not using anything but the defaults. We're not overriding them, but you could. You could change it so that the way that the images will blend together changes when you're drawing. So we're just using the basics. Same thing with the draw method. We're just going to use one of the most basic draw texture methods. We're going to draw a texture at a location with a specific color. And that color can change essentially how that image will be displayed on the screen. If you wanted to have a red tint to it, you could change it to color.red. Now we're going to see what it looks like. So here's the image displayed on the screen. It's being drawn. Now let's move the image around. So if we go to the update method, we can add in some very rudimentary, very basic movement code. All it's going to do is store the character position in a variable instead of it being hard-coded at 100, 100. And then we're going to adjust the position by 5 pixels every frame. Now you can see right here that we're going to change this variable from a hard-coded 100, 100 to that variable that we created, character position. So now when it's drawn, it will be drawn at the position that we are telling it to based off of the updates that are happening to that character position every frame. There we go. Super fast. Now, you might not have seen that because it moved by so fast. So let's just let's add in a character speed variable. And then what we can do is we can adjust that from, let's say, 5 to whatever we want. In this case, to make it on there a little bit longer, let's just change that to 1 so you can actually see it on the screen. This means that the image is moving 1 pixel every frame. So depending upon how fast your computer, that might be a bad thing. You know, we don't want to update it 1,000 times a second or 2 times a second. So let's see a different way we can do this, where we use the elapsed time since the last frame. Okay, let's run this, and we can see that it will now move 5 pixels per second instead of 5 pixels per frame. This is extremely slow. So what we're going to have to do is bump this up. Let's try 50 or so. Now it should be a little bit more realistic. And we've also controlled the movement again based off the elapsed time. As you can see from that, it was moving extremely slow, but it was moving faster than it was before. So let's try doing, I don't know, 75. Let's try 75. See how that moves. That seems to be about right there. Again, the benefit is that now the movement should be consistent regardless of how fast the person's computer is. This should allow us to have a more smooth, more fluid movement. If you really want more details about this, another person has already made a wonderful video, goes into possibly opinionated, but some good information about elapsed time. You can look into that video. All right, so moving it around is nice, but we want to control that movement. I mean, there's no point in having a character if you can't control where the character is going. So the next step would be, let's add in keyboard movement. So instead of updating it, what we're going to do is we are going to actually check for the keyboard being pressed, the up arrow, the down arrow, the left arrow, or the right arrow. In those situations, we will adjust the position based off of that. The getState method on the keyboard is an XNA or MonoGame class that provides us access to the keyboard information, whether or not each keyboard key is in a specific state, meaning is the key being pressed right now? Is it down? Is it up? Those types of pieces of information or data about that key. So hopefully if we run this, I should be able to move the arrow around using my arrow keys on my keyboard. And I can. So it's moving. It feels extremely slow, so I should probably bump up the number of pixels per second that we're trying to target here. But it is moving. One of the problems with this is that we're not restricting the image to the screen. And what that means is that as you're moving the image around, we could actually go off the screen. So if we run it again, and I press the left arrow key, the image will go past the edge of the screen and won't be blocked. And so we don't want that to happen, and there's a bunch of ways to do that, but the most basic is just checking the position to see if it's outside of that, if it's to the left of 0, or to the top of 0, if it's the Y, or to the right of the edge of the screen, or below the bottom of the edge of the screen. And so we can add these restrictions in after our position change, and what these will do is they will essentially bump us back or push us back the opposite direction of where we were going. Let's see, this should actually be the sprite, so this is called my character. Okay, so that should be updated now. So this is, again, restrict the arrow to the screen. Let's see if that works. So it looks like it's worked, but because I have not adjusted the position of my sprite, the draw position of the sprite is technically not where we would want it to be. It's drawing it right here. This is the starting position of the draw, and this is the ending position of the draw. Oftentimes in programming, what you'll do is you will actually offset the draw position based at the center of the image. It makes a lot of other calculations easier if you have the center of the image versus drawing it in the top. So there's a few ways to do that. One of the easiest would be just to offset it. So we could just subtract out the position of our sprite here. So let's go ahead and subtract off half of the width and half of the height. And let's see if that worked or not. now it actually goes to the edge, or feels like it goes to the edge, versus getting stuck way out here at 32 by 32. So now I can go to the edge down up there. And if I go down to the bottom, I should be able to go all the way to that position as well. Yes. So now I'm stuck to the position of this. And it shouldn't matter how fast we are. We could go up to 150. We're still going to be limited by the bounds of the rectangle that we have. That's all I wanted to show today. Again, it's pretty simple. It's just how to tell the content pipeline where your image is, what your image is rather, how to get it to load that, how to display it, and then how to change the position of where you're displaying something on the screen. And that's it.